Got it? Let me recall it one more time. Okay, abstraction is, let me show this. So abstract classes are the classes which will hide the implementation details and provide the functionality. Your abstract classes can have a variables, it can have abstract methods, it can have a normal methods, it can have a constructors, it can have a main method, it can have a blocks as well, right? So we will see that it is as similar as your normal class. The only difference is in the normal class we can instantiate, you can use them independently. If you go with abstract class, you cannot use them independently. Someone has to provide the implementation for them. Someone has to implement it. Some child class must should be there to provide the body for unimplemented methods. Unimplemented methods means your abstract methods. Okay, so simple example here, I have something called a shape class, which is a abstract class. Using abstract class, in this abstract class we'll have something called abstract method draw. So whatever the shape you inherit, like your circle class, square class, rectangle, whatever the class you write, you have to provide the shape. You have to when you extend the shape, you have to provide the body for run method. As similar as with this before example, as I shown you. So if you have any abstract method in a class, that class has to be must be abstract class. The class must be abstract class, and whoever extends that abstract class, whatever the classes extends the abstract class, they have to provide a body for unimplemented method. Unimplemented method. What is unimplemented method here? Run method. If you see in line number 4, run is unimplemented method. So you have to provide the body for unimplemented methods in the child classes. If you don't want to provide, if you don't want to provide any class, if you don't want to provide any class, that class must be, the class must be, it will give only two options. First one is either you add the unimplemented methods or you make your class as abstract. Either you provide the unimplementation methods like this, either you provide the body like this, or if you don't want to provide the body like this, you have to make your class, you have to make your class abstract. You have to make your class abstract. That's the only option you have. Okay, let's look at another example, abstract demo 2. In this, I'm taking abstract class as a bank, and I'm taking something called unimplemented method or abstract method, which I'm taking as get ROI, means rate of interest. So you can have any number of classes like bank ICICI extends bank extends bank. So whoever extends the bank, they have to provide the implementation for the rate of interest. So let me make it, instead of void, let me make it int, because I want to return some, interest. Okay, you can also have, you don't need to you can also have only sys out, and you just can say I am from this bank and this is my rate of interest. You can tell that I am from ICICI. Our rate of interest is, you can specify something. Okay, you can specify some value here. You can print, or you can specify some value here, like saying that 10. But because you have a return type, you should have a return. Okay, so the same way you can have any number of classes. You can have any number of classes here. You can have any number of classes. Instead of ICICI, you can say HDFC. You can say HDFC. You can say HDFC here. But the thing is that whoever extends the abstract class, they have to provide a body for it. Okay, and the rest of the implementation you guys go ahead and complete here. So in the main method. So as I explained you, an abstract class can have main method and all those things I have discussed, right? Let me show you that. Let me show you that. So let's go with new class. So now my class is abstract. I can select abstract from here. I can select abstract from here. So let's give abstract test. Abstract test. You can have a main method in abstract class because I'm selected as abstract. Now my whatever the class I'm going to create is abstract class, and I'm selected a main method. Let's look at here. Now by default my class has become a abstract class. Okay, let's look at guys here. I have a main method, no problem at all. I can have a variables. I can have a variables. String name. Okay, I can have a variables. I can have a normal methods. I can have a normal methods. Okay, and I can have a constructor as well. As I told you, I can have a constructor as well. So guys, please try to remember this is one of the important topic in Java. They will, if you are going as a fresher or if you are going as a Java experience, they'll surely ask an entry question from this abstract. Both the fields I need. I'm just saying okay. So it's get created. Let's look at, just remove this white space. So now I can have my abstract test as a constructor. I can have a normal methods like this. I can also have abstract methods. Abstract methods. Let me take a methods called abstract methods or public abstract void, and let me say method one is add. Let me say subtraction. Let me say multiplication. 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 Okay, if you feel it is a very big method name, you can just say multiplication or division. Okay, you can have a, so if you look at here, instance variable, instance variables, you can look at here constructor, you can look at here non-abstract method, you can look at here abstract methods, and you can also look at here you have a main method guys. Sir, what is the use? You said that they cannot be used as independent. Then what is the point to have all these things? So we will discuss. Please bear with me for 2 minutes. We will discuss each and every point now. Okay, we will discuss each and every point. Your main method, and as I said before, you can also have a blocks. You can also have a blocks. You can also have a blocks. Blocks are nothing but like this. If you write anything here, it will print. I'll show you when these blocks will be executed. So you can also have a static block. There are two type of blocks. One is the instance insertion block. Another one is static block. For the static block, you should have a static variables. I mean, if you want to use, you cannot use ID and all here. You cannot use the ID equal to 10, name equal to Okay, anyway, name equal to, you cannot use them here because it is a static area. It's if it is static area, only static people or static instance variables only can accessible here. Okay, so you cannot have anything others. So let me have one static variable here. Let me have one static variable here. Static variable is, you can take anything. Static, you don't need a public, you can have also public also, not a problem. String, school name, school name you can have. So here you can access only school name. You can access only school name. Data. You can have only school name. So now try to look at here. This is abstract class which has the abstract variable, normal variables, which has the uh, static variables, which has the constructors, where you have a normal method, where you have abstract methods, blocks, and everything is there. Even I have a main method here where I can have a main method, where you have a main method. So now what is the only difference is you cannot create an instance for this. If you are not able to create instance for this, guys, look at here, this is very much important. If I'm not able to create instance for this, so what is the point to have all these things? What is the point to having all these things? This is wrong, actually. It should not be this case because it is anonymous class. It is creating as anonymous. So remove this. I'm trying to do like this, but it will say, no, you cannot do this. You cannot instantiate the type of abstract classes. The type abstract. You cannot instantiate this. So if I'm not able to instantiate this, why should I have a variables here? Why should I have a constructor here? Why should I have, I understand abstract methods has to be implemented in child class, but what about the other methods? Why should I have them? Who can access them? Those can be accessed in the child class. Let's try to remember, whatever you're writing in abstract class, it has to be implemented by some other class. Correct? Yes or no? Whatever we write in the abstract classes, we cannot access them directly. It has to be implemented by child class. Yes or no? Let's say, guys, you have an idea. Okay, you have an idea. So that idea is nothing but your abstraction. So someone has to implement that idea, right? Either you or someone has to implement that idea. If no one is implemented, so no use. It's waste of, it's a waste. It won't be any useful. So even if you have an idea, so if you are not implementing it, no use for it. So you have to provide, or you have to provide implementation for it, right? Someone has to provide implementation. Yes or no? Are you guys able to follow? Kishore?
Yes.
Others? I'm not hearing anyone else apart from him.
Yes.
Sachin, Kishore, Masood, Ganesh,
Yes, Ravi.
right? So
Yes, Viral.
whatever you have, the someone has to provide implementation for that, right? So here also the same. So if I have a display method, so what is the user? Who will use this? So anyway, I cannot access here because I don't have instance. If it is a static method, I can access it. But it's not a static method, it's even a normal method. How can I access it? So the implemented class can access all of this. The implemented class, the child class can have he can access all of this. Yes or no? So can I compile the class independently? Yes. Anyway, you have a main method, you can go ahead and compile it and run it. I am from main, but rest of things are not accessible because you are not instantiating. So even static also is not instantiated. Only main method is able to access here. So rest of things are I'm not able to access here because if you want to access anything from the class, that class should be instantiated. How it will be instantiated? That will be instantiated by another class. Let me take another class here. Start demo 3 main method. You can extend from here only, guys. Okay, you can extend from here only. So you can browse it. So I'm making aware of the tools. I'm making you aware of the tools. You can extend from here only. What is your class name? Abstract test. Abstract test. You can select from here. You can select from here, and you can just say finish. As soon as you say that, see, look at guys here. The abstract demo. Sorry, this one. Your abstract demo. Then why it is showing error? Multiple. Okay, it's asking to create a constructor because I already have a constructor in child parent class. So if the parent class has abstract uh, with a variable, the child class must should have a constructor. Look at guys here. All abstract methods are showing me to provide the body. All abstract methods are showing to me to provide a body. If I don't want, if I say I won't provide a body for this, what will happen? It will say that no, you cannot access them. So you have to either you should provide the body for them, else you have to make yourself as a abstract. So I don't want to make myself as abstract. I can provide the body for these guys, at least empty body. So let's, for timing is empty body. So let's talk about other things. Okay, so let's talk about how to use these variables, how to use the methods there. Okay, not only normal methods guys, here I have shown you public method. This is very much important. Okay, this is a public method. So you can also have private method. Look at guys here. This is interesting. Ravi, you are telling that if anyone if anyone has to provide the implementation for them, they can access the methods. If they are public, then only they can access. If it is a private, how can they access? If it is a private, how can they access? Private is belong to your parent class only. Then what is the use of having private method in a in a abstract class? What is the use of having private method in abstract class? This is a very much valid point. Okay, this is so please try to think, how can I access this private? Why should I have a private? It is allowing. It's not saying you cannot. It is saying allowed. It is obviously fine to have a private method in a abstract class. But as I said, abstract classes has to provide a body in the child classes. Someone has to implement them. So what is the use of having a private method in abstract class? Because anyway I cannot access this in child class. Anyway I cannot access in the child class. Look at guys, if you want you can look at here. Anyway I cannot access. Anyway I need to, what are the things I'm able to access? ID, name, add method, display method. multiplication. You can look at here what are the things you can access. These are all notify, all are is not belong to your abstract class. These are belong to different. Your subtraction you can access. You can access school. You can access school name. You can access the main method, right? So what about others? I'm not able to access print. What was the method? Print. Let's look at here. The method print from the type abstract test is not visible. You cannot access. You cannot access the privates of your parent, private properties of your parent. If it's a private property of your parent, if you're not, if you cannot access in the child class, then what is the use? What is use? Anyway, I cannot access in the child class, then what is the use? My abstract class is allowing to keep a private. Anyone tell me why? Can anyone tell me why private methods are allowed in abstract classes? Anyway, they are not able to access in the child class. What is the use? Can anyone tell me?
We can use that private method in another abstract method.
Uh,
Private
it's,
method
uh,
in
it's a very very nice answer, very good answer. But I want a little bit loud, so I want everyone should hear that.
we can use that private method in another methods in abstract class and do the operation.
Very good, very good. So this private method can be accessed in any public method in the abstract class. Sorry guys, it's not copied properly. I can access like this. I can access like this. I can access this private method in any of the public method in the abstract class. So this anyway, this display I can access. This display method I can access here. Look at guys. Ad dot disp. I can access the disp method. Anyway, it's the public. So let me compile this. Let me compile this. Now I am from the instance initialization block. It's spelling is wrong. Your installation block in abstract class. I'll tell you why it is. Under ID, name, your private and private name also started printing. It means as soon as you access the public here, in the public you're calling your private method, you can easily access them. Okay, now coming to, anyway, you know that you can access the ID and name as I shown here. You can access the ID and name, ad.id, you can access ad.name, you can access, okay, but there should be somewhere in this out. Okay, so that's why it should be like this. Okay, so anyway you can access them. Variables you are able to access, public method you are able to access. Then abstract methods, you know, you have to provide the body for abstract methods. That's anyway you guys know it. Let's coming to constructor. Why should I have a constructor here? Anyway I cannot instantiate, anyway I cannot create object for abstract class. Why should I have, why should I have constructor? Why it is allowing to keep a constructor? Why it is allowing constructor? Why it is allowing constructor? Anyone? Anyone? Guys, anyone?
Safeguard the control.
Exactly. From the child class, from the child class, you can access the parent class constructor using super. You already I thought you guys are observed, but only one guy is observed. Look at guys here. This is my constructor. From my child constructor, I'm calling my parent class constructor. From the child constructor, I'm calling super class constructor. Superclass constructor. So superclass constructor is nothing but it is calling this constructor, your abstract class constructor. Okay, so now compile this code. You can easily look at here. I am from the static block. I'll tell you what is this now. I am from the instance injection block. These two I'll explain very soon. So you can access ID, name, your private methods. This is a public method. This is the method of the public. This is the private method. These are the instance variables. Those are instance variables. If you want to keep it very clear, you can say here, you want to keep it very simple. uh, Public method start, public method end. If I say outside this, your private method also will come inside the public method. So that's why I didn't say that. So that's why I kept outside. Private method start, and I can say the private method end. Guys, don't get confused. I know that most of them are not from the Java background. They may getting confused. Very simple. Abstract means a class like an idea. A class like an idea, a plan, like a plan. If someone will implement the plan, then only useful. If no one is implementing the plan, no use at all. So your abstract class also same way. Your abstract class also same way. So as I shown here, look at guys, your bank. Bank has some abstract method. If no one has implemented this, let's say I don't have all these child classes. So what is the use of having the bank class? No use at all, right? So the same way here also I'm showing you not only the abstract methods, because we need to understand what are the things can we have in abstract class. Not only abstract methods, you can have a variables, you can have a static variables, you can have a constructors, you can have public methods, private methods, blocks, and everything you can have in a abstract classes. That's why that's why your abstract classes are not 100% abstraction. The statement which I made last class saying that your abstract classes are not 100% abstraction. This is my statement I made in the last class saying that abstract classes are not 100% abstraction. 100% abstraction. It means that's why it is having a main method, it is having a constructor, it is having a public method. So that is the reason your abstract classes are not 100% abstract classes. So 100% of abstraction, 100% of the abstraction, complete hiding, we will achieve through interfaces. We will achieve through interfaces. I will show you now. I hope everyone is clear. Any doubts? So if everyone is clear about this class, I'm going to show you blocks. How to use the block, which block will call when, which block will call when. Is everyone is clear about the abstract classes? Any doubts?
Yeah, Ravi, can you just show me how it is that constructor is working, like through that super?
Okay. So from the demo, I'm calling my superclass constructor. Nothing. As soon as when you create object for the child class, the child will call its own constructor. That own constructor is calling a parent class constructor. The parent class constructor has ID and name. Okay, so let me run and show you. So let me create one more object. Here you see only one object. Let me create one more object. Let's say it's 82. Instead of 100, I'm passing 101. I'm passing Hadoop. Okay, so you can access this 82. You can access. See, your child class are only providing a body of this. So it means that he can anyway, he can access, add all these things he can access. Your child can access this. Your child can access this. Anyway, your child can access all these methods. I'm not going to show all these methods because this is as similar as your normal classes. So there is no much difference here. So that's why I'm not showing these things. You can implement your own body here. So I'm just writing only system.out.println to make you aware that. So we can do that. So along with this, I can have my own methods also. Along with this, I can have my own method. I can have my own methods here. Okay. So that's as similar as your normal classes. You no doubt at all. You can have as similar as your normal. Okay. You can have as similar as yours. The only difference is you can also access your parent here. Let's say when I say ad2.disp, ad2.disp, let's look at how it behaves. So first, these two I'll talk now itself. So don't worry about these two things, or how the static and instance is getting called, and so how others is calling. Your public method started for the object one, Java object. The first object was Java object, and your private method is called for Java object. Object one, ad2, ad1, ad1 in the your previous class. Okay, and this is object two, which is Hadoop. I'll tell you what is installation block, and these are very simple, guys. These are simple things which I was showing you here. These are so let me, so to show that you can access the variables also, to show that you can access the variables also. So nothing to confuse, don't get confused. Let's run this. You can understand easily. Now forget about these two things, and I'll tell you, this is your public method and this is your private method for object 1. For object 2, this is the public method, this is the private method. And constructor also getting called. How can you say that, Ravi, constructor is getting called? Did I given the 100 and Java for these things? So look, if you look at here, sorry, in this test, if you look at the test, who is giving the ID and name? Who is giving ID and name? Your child class. How he is giving? Through constructor. It means your constructor also getting called. Your constructor also getting called. Your constructor also getting
What is
called.
the meaning of super?
Super means you're calling your parent. Super class.
You're calling it. Yes, okay.
So let me show you this as well. So you guys will get the complete idea, complete picture. Oh, sorry, I executed only this part. So let me execute this. Look at here. As soon as you created object for your child class, your abstract class constructor is called. Look at guys here. Your abstract class constructors get called. It means as soon as you created a child class object, you are calling your parent class object using super method. So super method. So this is executed from the this line executed from the. Let me show you here. Let me show you here. These lines are executed from, what is this? One second. Yep. From here, line number 5. what I'm doing in the line number 5, I'm creating a constructor for the child class. Line number 7, I'm calling a parent class constructor. So when I call the parent class constructor, these two lines are printed. These two lines are printed. And coming down in main method, line number 35, I created object with Java. And 37, I'm calling public method. This is your public method. So inside the public method, you're calling private method. That's why this. Okay. And third one is the second one. So again, I'm creating one more object at the line number 43. If you guys see my screen, at the line number 43, I'm creating one more object. So how many times you create object, those many times your constructor will get called. It's a pretty simple one. We know it. So how many times you create object, those many times your constructor will call. So your parent constructor is called here. And public method, private method. Public method and private method. Is everyone is clear about the abstract class? Is everyone is clear about the abstract class? Any doubts? Any doubts, guys?
No,
So I'm hearing only one voice, one or two voices. I'm not hearing anyone else. I don't know whether they're clear or not.
No, Veera.
Okay, Kishore,
No doubts.
No.
Kishore.
Yeah, clear, Ravi. Yeah.
Okay, okay. Nikesh, Teja. Oh, very good. So everyone started telling me. No doubts. Good. So now let me show you, as I promised you, I'm going to show you about blocks. About blocks. So let me create a separate package for it because it will make you very much clear to understand. com.fira.blocks. Okay, there are two type of blocks. One is instance installation block. Another one is for static block. Another one is static block. So in shortcut we'll call IIB SIB demo. IIB SIB. IIB means instance installation block. SIB means static installation block. Static installation block. Okay, coming to here. As I shown in the previous example, let me have some variables to make you very much clear. So I have normal variables. I'm taking static variable as well. I have taken static variable as well. So let me have two constructors. Two constructors. So one is with one variable, one is with the zero variable, one is with the variables, one is with the zero variables. So one I'm creating with the variables, I mean parameters, variable in the sense parameters. Another was I'm creating with without fields. If you don't want the fields, what you need to do, you just say deselect. So one is with no arguments, one is with argument. You can have a super or not, it doesn't matter really. So I don't want the super because people may get confused. Okay, next one is installation block. Instance installation block, IIB. So the main important of our main use of the instance installation blocks are, our blocks are, the block is nothing but a set of statements in a single brackets. Set of statements in a brackets. That's a blocks. Static block means accessing all the static variables. Okay, here I can have my own things. I can have initializations. The main purpose of the IIB is initializing instance initialization. For initialization, the main purpose of this IIB is for initializing the variables. Initializing the variables. So you can here you can initialize id equal to, so you can say here, okay, if this dot id equal to 0, you can say this dot id equal to 100. If this that's up to you guys. I'm just writing a simple no simple um, logic. So okay, it's not always, it should no need to be always correct. Okay. I can say the default is null. Here you can say this dot name, you can give something Hadoop. Okay. Coming to static block. Coming to static block. So static blocks are meant for initializing the static variables, only static variables. You cannot initialize the normal variables. Okay, you cannot initialize the non-static variables. So what happened this? Let me move to upper line from SIB, and we have something called school name. School name, right? Or school? Just a school or school name? Just a school. Okay. Data solutions. Data solutions. Now look at guys, when normal block will call, when static block will call. This is very much important. Okay, this is little important. That's a little important. That's the main purpose of this class. So when IIB will call, when will be called, need to understand. So look at guys here. I'm going with only one constructor with a zero argument constructor. With a zero argument constructor. First, let me demonstrate this. SIB is called, IIB also called. SIB is called and also IIB is called. So to make a little more clear, let me have public void print method. Who will print the values of ID and name. So I can copy from other class. So because I'm little lazy, let me copy from here. Okay. Yep. You can also print the school name. Okay, no doubt at all. You can also print the school name. Okay. Let's go ahead and compile this code. Oh, because I'm not calling this method, I have to call this method id dot print. Look at here, something went wrong. Yep. So from SIB, from IIB, ID, name and school name. Okay, ID, name, school name. Okay, now for one constructor one SIB static block, one IIB, one static block, one IIB, and the methods. The others are you just can you know not to worry about it. This is just a method call. Okay, just a method call. So the only main thing is to understand when your method is calling, whenever SIB is calling, whenever IIB is calling. That's the matters. We'll talk about that. So your SIB is calling first, then your IIB is calling next for one constructor. For one constructor. Let me have one more constructor. Let me have one more constructor with the arguments. This time I'm taking with the arguments. This time I'm taking with the arguments. So I'll pass here 1000 comma the already Hadoop is there. This time let's say Spark. If you look at here, SIB called once, IIB called twice. IIB called twice. Why IIB called twice? Why IIB called twice? Because your instance installation block will call how many instances you are creating. Those many times it will call. How many instances you will create? Those many times it will call. How many instances you will create? Those many times it will call. Instance installation block. How many instances you will create? Those many instances will be created. So, and one more thing, let me put one more thing, because who will call when, that we need to understand, right? First your constructor will call, or your instance block will call. No args. So guys, I'm taking little more time today, sorry for that. I just want to complete this and just will finish. Okay, look at guys here. First your instance installation block is calling, then only your constructor is calling. First your instance installation block is calling, then only your constructor is calling. Look at guys here. First your instance installation block is calling, then your constructor is calling, then your constructor is calling. It means as soon as you initialize, as soon as you create an object, first it look for the instance installation block. First it look for the instance installation block. Is there any instance installation blocks? Yes, then it will execute that first. It will execute that first. If no instance installation block, then it will call, your, after calling your instance installation block, it will call your constructor. And what about SIB, static block? It is called only once. When it is called very first statement. Sir, is it called before main method? Is it called before main method? Can someone tell me, is it called before main method or after main method? Look at here. It is called before main method. What does it mean? Your static blocks will be executed. Your static blocks will be executed when class loads into JVM. When the class will load, when you compile, as soon as you started running, your class will be loaded into a memory. As soon as the class is loaded into memory, the very first thing is it will load all your static blocks. That's why they call them as static blocks, class level blocks. They will get loaded into the memory at the time of class initialization, class loading into a memory. If you understand your JVM, first it will load the classes, then only it will run. Without loading a class into memory, it will not run. So at the time of class is loading into a memory, that time only your static block will be executed. Static block will be executed only once in a life of a class. Why? Because the class will be loaded only once for each run. Each run it will load only once. But your instances, you can create a number of instances. Your IIB will call how many instances you have, those many times your IIB will call. Your static will be called only once in a life of that class. Are you guys clear about the SIB and IIB blocks? Are you guys clear about this? Anisha, Ganesh, Kishore, Teja and Venkat, Sunil?
Sir, what is the use of IIBs and SIBs?
That very good question. See, SIBs are if you want to initialize any variables before your class, any object executes. Before any object executes. It means now, even though before my objects are get created here, my school name is available. If you see this, my school name is already available before executing all this main method, all this constructor and all, because it will load first into the memory. The main purpose of this initializing the objects, initializing the variables. The main motto of initialization blocks is initializing the objects. Okay, you may say that, sir, I can use by using constructor. Anyway, I'm doing the same thing using constructor. Yes, so you can use through a constructor. But if you want before your constructor, you want something to be something has to be initialized, you go with IIB. You want anything before, I mean, so not before blocks, instance block, or not before constructor. You want to execute before initialization block. If you want initialize something when the time of the class loads into memory, at the time of the class loads into memory, go with a static block. If you want to assign some values to your variables at the time of class loads into memory, go with the static blocks. And when at the time of initialization, you want to initialize before your constructor, go with initialization block. That's the only use of these two. Okay, we will see more usages of static in the real time, but not very less of this. So I hardly see this in my 8 years of experience, but the static installation block I have seen very frequently. Clear, Anisha?
Yes, Veera. Thank you.
Anyone else?
Ravi, can you give some real-time example for static work?
I'll show it. Not now, it's already getting late. So I'll show one real-time example. I'll show on the real-time code as well, not to worry about it. Most of the times it will be using for constants. I'll show you that, not a problem. Static variables. Okay.